Howdy, everybody. Hope you're doing well wherever, whenever you are. We're here for day 10 of Advent to Code 2016. So far, the days have seemed pretty good. I think the places where I could probably improve is just trying to do things a little bit more efficiently, right? Don't overanalyze, don't overthink. I'm trying to go for that competitive solve it, get it done. But I think the days overall have been not too tough. Feel like I've been able to solve them in a relatively normal amount of time. But anyway, it actually might be interesting to see what the leaderboards are, like how fast some of these solve. So see if I can even get close. But anyway, let's go ahead and get started with the day. So this one is balance bots. I should say I actually started reading this, but then ran out of time. So I've read it, but I haven't done really anything with it. So I have kind of an idea already of what I want to do, but we'll read it and then we'll go through it. You come upon a factory in which many robots are zooming around, handing small microchips to each other. Upon closer examination, you notice that each bot only proceeds when it has 2 microchips, and once it does, it gives each one to a different bot or puts it in a marked output bin. Sometimes bots take microchips from input bins too. Inspecting one of the microchips, it seems like they each contain a single number. The bots must use some logic to decide what to do with each chip. You access the local control computer and download the bot's instructions, your puzzle input. Some of the instructions specify that a specified value microchip should be given to a specific bot. The rest of the instructions indicate what a given bot should do with its lower value or higher value chip. For example, consider the following. Value 5 goes to bot 2, and so on and so forth. So then it goes through like what happens given these things right here. So you either have value ones where it's like 5 goes to bot 2, or you have rules for bots. So it says bot 2 gives its low to bot 1 and its high to bot 0. Or it could be like this one where it's like gives the low to output 1 and the high to bot 0. So given these rules, initially bot 1 starts with a value 3 chip, and bot 2 starts with a value 2 chip and a value 5 chip. Because bot 2 has 2 microchips, it gives its lower one 2 to bot 1 and its higher one 5 to bot 0. Then bot 1 has 2 microchips. It puts the value 2 chip in output 1 and gives the value 3 chip to bot 0. Finally, bot 0 has 2 microchips. It puts the 3 in output 2 and the 5 in output 0. In the end, output bin 0 contains a value 5 microchip, output bin 1 contains a value 2 microchip, and output bin 2 contains a value 3 microchip. In this configuration, bot number 2 is responsible for comparing value 5 microchips with value 2 microchips. Based on the instructions, what is the number of the bot that is responsible for comparing value 61 microchips with value 17 microchips? And then this is the puzzle input. You can see it's a bunch of rules and a bunch of or a bunch of values get given, and then there's a bunch of bots as well. So anyway, that's the puzzle. Yeah, so like I said, I just started looking into this when I ran out of time. And so I think what was going through my mind at the time was this is just like a simulation problem. I mean, there's a value 17 in here. It goes to bot 198, right? And then 61 is the other one. Is this one? It goes to bot 61, which is like a different bot, right? So there's no like, I think what you're probably meant to do is run the simulation. So you're going to collect all the bots, you're going to give all the values to the bots, and then you're going to have some list like you could have it be kind of like a vec deck where you have some list of like, here's the bots that are like ready. And then those ones that are ready, you know, distribute their 2 values how you would, how you'd want where they should go. And then anytime that would give a bot 2 values, you then push them on the list of here's the things to process. And eventually, and so what I think you'd eventually do is if you ever got to the, if you were ever popping a bot off and their 2 values were, was it 17 and 61? Yeah, if those were ever their 2 values, that would be like the quote unquote bot that was the answer, would be my thinking. Excuse me. So that's how I think I would solve this. So what we need to do then is I think we need to be able to parse these. So our parser probably should return 2 vectors. There's probably like one with bot rules, and then there's one with bot values. And then we probably need to maintain like vec of vecs for the bots and where they send the and the values that they currently have, as well as that little like to be processed vec deck that's like, here's the bots that are ready. And then we'll need the output containers as well. It doesn't say anything about the output containers, so maybe they're like a sink. I can just delete the values presumably. But then I basically, I think I just keep going through the simulation of like finding bots with 2, moving them, new ones get added to the list. I keep doing that until I find one with a 61 and a 17. So lower value and higher value. I could probably, if I just have like a vec, I can just do like the min and max to get the lower and higher. So that's probably what I'll do. Okay. 17 and 61. So I'm going to put this stuff in here because I kept having to look last time. Then hopefully I don't have to look as much. So I think we want to write a parser for these. Well, and also the question is, do we have any data types we want to use? Like this, I think we can just have a tuple of ints. For the bots, maybe we have rules. Like we have a bot rule that says, here's what you do to the low, here's what you do to the high. So you can give them to outputs and bots as well. So we probably need to have an enum for that as well. So let's just start doing that. Enum. Location. And so it should go to output usize or oops. Bot usize. How am I going to parse these? Probably, do I just like split by space? And because it looks like they're pretty much the same. Like this is interesting. This is interesting. So like I can do something like impl location, and we'll have like a new where we get the like the where, and that's a keyword. So where is a stir, and or like a what and a value stir, and we'll return a self. So we match what to output, and that should be a location output value dot parse dot unwrap. We want to do the same thing for bot, like that. There we go. Easy enough. So the next is a, oh, I guess I misspelled that. When you have a struct bot. Oh, yeah, like the rules. Bot rule. The low is going to be a location. The high is going to be a location. And then we'll impl bot rule. Do we want to keep the ID? I think we'll just keep them in vectors. Or like a hash map. We'll keep the rules in a hash map or something like that. Okay, so what are we gonna, what will we give it? The low, what, low value, high, what, high value. If this doesn't make sense, it's just I think what I'm thinking is I'm going to parse these by just split by space, and then I'll just pass like this and this to like this, and it will create this based on these. So like low will be, oops, self, low, location, new, low what, low value, and then do the same thing for high. I guess I need these types. Like that. Okay. So what is my actual input then? It's going to be this with a vec of usize for the values, and then a vec of bot rule. Like that. So the init is going to be vecnew, and oops. This is going, so the accumulator is this in line. And so what do we do here? Parts equals L dot split whites. Split by white space dot collect. Like that. So now we have the parts and we can match on part 0. So if it's value, we want to act 0 dot push. So 0, 1 parts 1 dot parse use unwrap parts 2, 3, 0, 1, 2, 3, 4, 5. Like that. It doesn't like, oh, is it? Well, we'll see. So if it's bought, otherwise we have a panic invalid line L. How does fold work? Fold every element into accumulator by returning the final result. Oh, I return the accumulator at the end. That's the issue. Like that. So yeah, I need to do this one as well. But first I need to do act.1.push. And it's going to be this, which is bot rule new. So I'm going to do bot rule new. And I want to do the lows. So 0, 1, 2, 3, 4, 5, 6. So parts 5, parts 6, 7, 8, 9, 10, and 11. Does that work? Okay. So now I'm going to get these two things in part 1. I don't need this anymore. I may have regrets though. We'll clean it up later. So I think we can do that destructuring thing, can't we? So we can say like let values rules equal input, like that. Does that work? And then we say so we want to track the current values of each bot. So I think we can do that in a vector. Because we know how many bots there are based on the number of rules, presumably. So we say let they were holding him, right? Handing no, it proceeds as 2 microchips. I guess I don't know exactly what they're how they're numbered, so I'm kind of inclined to do this. Same thing with this one. They're both going to be U sizes, and we'll slowly update them. So to update the bots, it'd be values dot iter dot for each kv bots dot entry k dot get. Isn't there like a or default dot push v? Oh, this is going to be a vec u size. So something like that. It's going to want me to dereference these, huh? Okay, so now in my values, I have all of, sorry, in my bots, I have all of them. So I do need to build which ones are ready. So we want to iter over the bots. And we want to filter where v.lane is greater than or equal to 2. We map that to their ID. like that. I guess I don't use this either. So these are the ones that are ready. These are my bots. These are my outputs where they go. And then these are my rules. So I think I just go like, while let some ID, which is, so this is like the bot ID equal ready dot pop front. We want to match. We probably want to get the IDs or get the values first. So let values equal bots dot get ID dot unwrap. And then we do let low equal values dot min dot unwrap. And I is max, but I guess I got an iter. And what does it want me to dereference? Okay. So I have the values, the low and the high values now. Oh, and now I can do my check, right? So if I say if low equals 17 and oops, and high equals 61, we want to return ID. So I think we do this. It's going to make more sense to do this, so I don't have to do it all the time. It'll also dereference it, I guess. I wonder if there's going to be ownership issues. We'll find out. Okay, so that's if we found it. Otherwise, we haven't. So now we want to do let rule equal rules.get id.unwrap. I guess we can just match on no, because we're going to do each of the rules one at a time. So it's going to be like match rule.low, right? These are the rules are oh, it's actually not this. It's this. We actually don't care about the output, right? Like that's just a sync. Oh, these aren't sorted. The rules aren't going to be sorted, huh? Like I was looking here. You just have like random rules all over the place. So I need to create rules as well. Let rules equal fx hash map usize bot rule. Oh, should I have this one? Yeah, because they're not. I'm not actually doing this right. This should be like this. Oh no, I just do this. And then this one I do act.1 dot insert parts 1 dot parse dot unwrap. Is it able to figure that out? Yes, it is. Okay. So now I do have it by ID. So what I actually do is I do rules dot get. Wait, did I do something up here? No. This. And so now given this ID, what do? I do bots dot entry this ID dot or default dot push low. I want to keep this too, because if I say, I should say let entry equal because now I want to say if entry.line, it's not an entry now, but it's a list or values. We want to ready dot push back this ID. What doesn't it like about this? Why doesn't it need to be mutable? I literally push right here. It doesn't like these ID, so I can just do outputs dot entry ID dot or default dot push low. Maybe we'll use it for part 2. Oh, do I have the outputs wrong? Yeah. Okay, so now I just do the same thing for the high rule. Oh, that's a bug. So I want to push low here, push high here, and high here. What does it think? Struct bot rule, field of struct. Dead code. High, low. It's right here, match high. Do I have some kind of... Okay, it's still returning 0, which is like down here. So it must be be never getting these values. Does this work now? I've been trying to do this in different puzzles. Never runs. So there are no readies. Value 5 goes to bot 2. So 1. So can I find that in here? Value 2 goes to bot 143. So there's a 143 in here somewhere. No, it's the wrong way. I'm doing it the wrong way. There we go. Okay. Das was a bug. $93. Should we try it? Say a little prayer. That's right. Very good. Okay, that took a little bit of time. I think there was a lot of like parsing and figuring out where the numbers are. I feel a little slower. I'm getting good sleep. Is that an excuse? Doesn't count in competition. Let's look at part 2. And then we can do some refinement. What do you get if you multiply together the values of the chip? What do you get if you multiply together the values of one chip in each of outputs 0, 1, and 2? So do I just run it until I'm done then, is what it's saying? Duh. So I don't break here. And then presumably I... No, it's outputs, huh? Outputs dot iter dot flatten dot product. Oh, I need to map. I always forget this input thing. Da, 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 da. Hey, yo, that can't be right, right? Oh, this is saying I can flat map. Oh, I have a bunch of them. So I need to filter. Outputs of 0, 1, and 2. So is that right? That is. Okay. Not too shabby. Yeah. So it was like a simulation thing. These happen from time to time, right? You do, it's like basically wants you to run a simulation. Sometimes you have to like do the simulation in a more interesting way. It looks like there's only one output. So we could make this faster and like do this. And then I think you can do like, I guess you can just do this, right? If there's a better way to do these, it would be interesting to know. Because the reason why it was failing is it's like this returns a nothing and this returns a bool. So it's like, oh, they're not the same. So you have to like wrap it and do this and then it magically works. It does not. Oh, because this, now I can just do, wants me to do this. I mean, is that the right same answer? Yeah. Okay. So that feels better. Like that. I mean, you wouldn't know. Maybe if I had read, it may say in the puzzle, but because there's only one output, you know, we can just instead do it like this. I suppose we can keep it the other way though. Just, I mean, I don't think it changes anything. I mean, maybe the puzzle says otherwise. That'll be like a future me problem, I guess. I was trying to think like we can run the simulation and like for part 2 we don't want to quit. For part 1 we do want to like break when we hit this. So we could have like this sim input, but you also give it a like a stop function. Hmm. How would I do that? Like, what was going through my mind is we want to run the simulation, but for part one, there's no reason to keep going through the whole simulation. You just stop when you get to this one, right? And then for part two, you want to run all the way around and like get the outputs. I guess you could still do this like this. So then we say, we're just going to call this FN right here. And and we're actually going to return an FX hash map of usize vec use like that. Like that. What doesn't it like about this? Oh, this right here. Because this is we're actually going to call F on this. Ooh, so we actually want to have it return a bool. So we'll say like if F, oh, I only need 2 because I can actually return the ID. No, I can't return it. I'm going to give them the ID as well. Oh, it's called stop. So we run the sim. So for part 1, we'll say let mute bot equals 0. And then we'll say sim input low high bot if if low equals 17 and high equals 61, bot equals bot. Oh. Solution equals bot. And then we return, oh, I guess we can just do true. Else false. Okay. So that was just because I'm updating values inside the closure, it has to be an FN mute, even though like I'm not changing any of these values. So we do that for part 1. And then for part 2, we do let outputs equal sim input. We're not going to do anything. We just always return false. And then we do outputs 0 times outputs 1 times outputs 2. So did it again. Any be pointers because we're doing references to the object. Oh, but what wasn't like here? Oh, I didn't do it this way. I did oh, I have to write that again. Dot iter dot filter one 2 dot contains. Okay, I get to do this right. I missed another thing again. Dot map v dot product. That okay. So that kind of simplifies part 1 and part 2 into like one thing. You could argue that is this really cool? I mean, there is a lot of work going on in here, so having this like here's the stop function is like helpful. Maybe we don't call it stop, we call it stop is fine, I guess. But the idea is we pass a stop function that we run to see, hey, we found the value, and if we did, we're done. So there you go. Let's see. Yeah, so we parse outputs. We parse bot rules. Don't need this anymore. Oops. Okay. What else? Sometimes I wonder if these actually look cleaner. I'd be interested in opinions. Like using fold versus just creating 2 values and then doing a for loop. It's definitely not as indented nearly as much. And like the accumulator 0 doesn't make quite as much sense as like having these 2 things. Does that make sense? Like what we could do is let values equal vec new rules equal fx hash map default. So we still do like this match, but now we do values dot push and rules dot insert. they still have the same issues before with like the. So I do need to keep these in here, but then I do values and rules. Oh. Does it not know? Oh, maybe it's because I'm not returning them. So what do you think? I mean, in hindsight, it's like not that much cleaner. It does feel a little bit cleaner. Can you destructure the accumulator? Like this? Okay. I mean, that does make it look a little cleaner. Guess. Anyway, you'll tell me what you think about that. But I think, is there any. I can probably create the bots from this. Can you? I have them in the wrong order. I could go fix the order upstairs or up in the other function. So you do value bot value. It's a little ugly, but I just dereference these. Maybe you can ask someone. Claude. If I have a vec usize, and I turn it into a hash map usize vec usize in Rust, I'm sure you can. I'm just doing it wrong. Although also maybe FX hash map, maybe it does it. Pairs into iter. Okay, you can do iter tools. So this is like very traditional. Fold. Iter tools. Okay. We could try that. Into iter. Into group. Okay, so I should fix the values up here. So I don't have to do this. Expected iter usize to be an iterator that yields blah, but it yields pointer usize. Okay, so that map was normally you do this, I would think. Oh, I don't have. Wasn't even spelling that right. That. And then it says I can actually just do this. Okay. That thing I was doing before is like the equivalent of cloned, I guess. Can you actually do this up here? I've never done this before. So you can destructure in the function call. That's very cool. Okay. That's a nice little shortcut. Sometimes, though, I wonder if those things make it hard to grok, right? Like, what I'm saying is value and rules come from input, so I guess it would make sense. I could put this into an apply function. So if I have an impl, I have my own rule and I need to, what do I need? There's the potential for me to push back if ready. So I need the values and the ready. The ready is a vectec usize. Oh, and I need the outputs as well. So I need bots, outputs, and ready. It's a lot, but we can try it. The bots is a mute fx hash map of usize vec usize, and the outputs is a mute fx hash map of usize vec usize, and the ready is a mute of vec deck usize. But I also need to give it the match self. We're going to match on self, but I also need to give it the value. This is the usize. It's going to be this and this. I couldn't spell. What is that? That location bot usize. Mismatched types expected. Oh, I need to dereference it once, maybe. Same thing down here. So yeah, I would then do rule.low.apply bots outputs ready low like this. Ayo. Expected hash map usize vec found hash map. Oh, do I need it? This one's actually a hash map and not a. So can I tell this what it should be? Can it not make a FX hash map? Okay, so what is this into group map? It returns specifically a hash map, so not an FX hash map. Okay, so that way doesn't work if we want a specific type. So I can do the fold. So values are fold FX hash map default. Sorry, we spent a lot of time doing this. Maybe it's not worth all this refining. I mean, for me, it's fun to learn. So we do that. And we want to accumulator.entry key dot for default dot push v back. Perhaps do this and this. Or I think I can do this, right? Gotta do this and that. Okay. And now we do rule.high.apply high. Is that cleaner? Don't use itertools anymore. So that's I've forgotten what the original answer was. 93.47. Yeah, that's right. Okay. I mean, I'm not totally a fan of this because it feels like, I don't know, I waffle back and forth with a lot of these things. The problem is like this apply is you're saying, oh, give me the bots and the outputs and the ready, and then I'll go update them for you. Like, presumably it's easier to do that here yourself. Like, this feels kind of, I don't know. It is now fewer lines, so you can potentially see the whole logic of what you're doing in one chunk. But it may have been easier. Oh, you know what you could do? Could you have an apply closure? We could have a function in here that does it as well. Like a closure that captures it. Should we try that? So what you do here is you say let mute apply equal, and what do we need? We need the rule. And the value. We match rule like this. So these changes. I actually don't think I need to do this part, but then I can call apply rule.low and rule.high. I could have this be a reference to a bot rule. This be a usize. Oh, this is going to be a doesn't like I think there's probably a way to do this without clone. Like it wants you to do the that. This is going to do a mutable hold, get a hold of it mutably. Like this is, so the issue now is that like this is going to mutably borrow bots, and then this immutably borrows it. So like you could put it down in here, and now it probably works. Yes. Yeah. Does that make it more readable though? I mean, technically you're only doing this once. I'm not a fan of this way either. I don't know. You'll have to tell me what you think. I'm going to stop right here and leave it like this, but tell me how you prefer to do it. The thing is like you kind of want to have something simple like this. Well, what you'd really like to have is something simple like this, because it's very easy to see just from like that position. Oh, here's the general logic that I'm applying in my while loop. I don't know if you've ever, I have some really old C code from other people that have like these loops that are like 700 lines long, and it's really hard to read, and you kind of want to like break it up into chunks so that it's more readable. So I think what I'm going to do is go to this way. This feels the, to me, this way feels like the most readable, even though you are passing these. Here's the thing you could do. You could imagine there being we could create a data structure, and I'll do that in the other thing. I've spent way too much time on this. You could imagine there being a data structure that has this, and you just say, hey, apply rule.low to this value, and the data structure has these things. I think that will work. Yes, I'm just thinking about the borrow checker. If you have some data structure that's like the combination of these, can you immutably borrow just the bots and then mutably borrow the whole thing? I don't know if you can do that. So you may run into a borrow checker. I'll try it out later, but let me know how you did it. Did you do it different? Were there some things you how did you solve it? I'd love to see how you solved it. I spent way too much time doing my own stuff, but I'll submit this answer as is. I spent more time refining it than I did solving it. So this is another one where just probably just get her done, right? But it was fun to learn. So let me know what you think, and yeah, we'll talk to you next time. Bye, everybody.